doesn't it? It doesn't.
Okay, so
not
today
just
we're
how
going to
far
be
it goes,
finding
but
the
how long
instantaneous
it goes
speed
down.
basically
of
it's gonna
an
be
object
like
that
this.
is dropped from 3,000 feet
Mhm.
and falls at a speed of 6t
There's no air
cubed
resistance.
meters per second
Mhm.
in
So
t
that means
seconds.
There's a
So
concept
in order to find the instantaneous
that
speed at say 3
using
seconds,
these vectors that we can break things up, right? And so there's a concept of orthogonal vectors. In 2 dimensions, all I need to do is break things up into 2 vectors and I can get any direction. So that means I can break this up into a vertical direction and a horizontal.
so to find the instantaneous speed at 3 seconds, we're going to be able to need we're going to need to be able to take the limit of the difference quotient of 6t cubed. So
So then you need to know
let's
what
figure out, let's use the difference quotient to
the
find
initial in the y direction is
the limit.
and what your v initial in the x direction is.
So the
So
difference
20
quotient
cosine
is
Yes,
the f,
exactly,
the
right?
x plus h,
Calculator.
So you have that.
minus
Yeah.
Well,
f of
the
x
actual value doesn't matter.
Okay.
over
Because you have that. Now, the next question is,
h. We were trying to find the
you need to
limit as
figure out
h goes to
how
0.
long it's gonna take. You need equation, so this is just velocity, but now you need position equation.
So now we're going to plug that
You
in.
need a position equation in the y direction,
Mhm.
and you need a
And-
position equation in the x direction, right?
6
So they
times
have to be functions of time.
Okay.
t plus
So
h
this is what is called the
Cubed.
kinematic equations. So you could look it up in the
Minus
textbook, or you think about it.
6t
and you write it.
cubed
I don't know.
over.
I don't know which equation this is. We have so many equations.
Did you?
Is
watch
it? Oh no, I haven't watched the.
Now
one
we're gonna do
on
that
for
out.
the day before the test.
Oh, you
So-
should have watched that one,
Oh,
because
those
it
three?
has examples. But this is in the book,
but this homework was for like 2 nights ago.
but it was in the book, it was in the reading for 2 nights ago.
We're not supposed to read any.
Yeah, it's all there. Even if it doesn't say if it doesn't
So we're
say
gonna be getting
anything, it's up-
6
this is an
times
honest course.
t
Mhm.
plus
You have to
h,
touch it, so you have to read it.
Okay.
and then
So the equations are
t squared
y initial plus
plus
t zero,
2
initial in the y
th
direction times delta
plus
t.
h squared.
Is 1
We have
half
seen this. Yeah.
Now we're going to multiply
times the
that
force over the mass times delta t
T
in the y direction
cubed
times delta t squared.
Mhm.
And then
plus
same thing in the x direction.
2t squared h
Oh, and then you set that
Plus
equal to the 22 sine inside.
h squared
Well, you don't set it equal to it, you use that information.
plus
So then,
h
and these
T
equations are true as long
squared
as
The force
these
is
forces are constant, exactly.
plus
So in the x direction, there's no
2
force in the x
T.
direction.
Mhm.
h
So then
squared
this goes to 0,
plus h cubed.
and you only have to deal with this.
And now we're going to see if we can factor anything out and cancel.
So the question is, let's see what we know. Do we know our initial y
And
position?
so we'll add in this
0.
minus
Yeah.
6t
Do we
cubed.
know our final
here.
y position?
0.
Yes. And we know our
And
initial y.
we'll also
y. I'm just going to leave it like that. Delta t
distribute
plus
the
1 half.
6.
Do we know the force in the y
First.
direction
So-
divided by the mass?
Now we're going to
It's
get
equal to acceleration,
6t cubed,
right?
which will
Due
cancel
to-
with that negative 6t
What's the
cubed.
force in the y
Oh,
direction?
gravity.
Gravity.
12t
So then,
squared h.
right, so it'd be negative 9.8 in this
Because it's-
case,
Okay.
right? Because y is positive in
Mhm.
that direction. Times delta t squared,
Squared plus
right?
Mhm.
So here we have an equation with just one variable that we don't know, so we can solve for that delta t.
Mhm.
2.
So that tells us how much time it's in the air.
Okay.
And then here, do we know the initial x position?
0.
0. Do we know the final x position?
No.
No, so that's just, we know our initial x velocity, right,
Mhm.
from there.
T
Delta
h
t, we don't
squared.
know, but we can figure out from here.
Mhm.
So that's how we know everything. So you solve for delta t here, and then you plug it in here and you get your final x
Squared.
position.
Okay.
Does that make sense?
Okay, so, okay, and then you know delta t from solving that. And
Right.
how come you don't know the final x position? Because we don't know where it lands.
Yes,
But how come we do know the final y because it's on the ground?
exactly.
Now we can
Okay.
cancel the 6t
Okay, that makes
cubed.
sense.
Right.
Okay, thank
And now all of our
But yeah, you
all
should
of our
definitely
terms
always-
here have an
if
H,
you-
so
If
we
you
can
run into a
factor
problem and you don't know how to do it,
an
you
H
should just
squared.
go back to the reading.
we can factor at
The
least
book
one
has-
H out, so we're gonna
Every problem
do
we
that
get,
and
there's an
factor the
example
H
in
out.
the reading.
Mhm.
So if you just go through the reading, it actually
H.
explains everything.
Okay,
If the
12
videos don't explain something,
T
they should do the
squared.
reading.
plus
okay. And, for some of the graphs
H.
that, like, a long time ago, they like asked us, are they cusps or corners? Some of them like weren't fully cusps or corners. Like if it was like what is that?
That's a corner.
But, so a corner doesn't have to be a 90 degree,
No.
as long as it is
A
two
corner
straight
looks
lines.
like a corner. But remember,
12
corner,
T H.
it doesn't really, that's not really the reason that's important,
Mhm.
okay? You gotta go by the definition. The definition of
Plus.
differentiability is this limit has to exist
Square.
at that point.
Alright, so
And it must be continuous.
at this point we can cancel
So
out
the reason
H,
that corners,
and we're just
that
left with
corners are important,
limit
the derivatives don't
as
exist.
H approaches
They're
0
continuous, they satisfy this,
of
but they fail this.
this.
Because this tells you the slope, right,
Uh-huh.
at any point. So if you approach from this side, you're gonna get one slope.
Mhm.
If you approach from this side, you get a different slope.
Okay,
Since it's different, then that limit can't exist.
okay.
Because for a limit to exist, it's gotta be the same on both sides.
Mhm.
So that's why at cusps and corners, that limit doesn't exist. And it will not be different.
Okay. Yeah, any more questions? It's just a lot of writing.
Of 12T squared
Yeah, and we should
Plus
we should have the product of motion rules just
6.
Memorized, you should have
T
power rule
H.
memorized.
Yeah, that's
Plus
good. The product of motion rules.
6T
Yes, that must be
squared
memorized.
Okay.
Plus
Find a way to memorize.
12
Okay. Okay,
TH
thank
Good.
you.
Alright, you're welcome.
6 H.
But you should watch the
Right.
videos the ones like we said before.
So since
that
H
has
is
all those
approaching
examples.
0,
Uh-huh,
the terms that include H's
thank you.
will become so insignificant, H will approach 0, so when it becomes 0, the term becomes so small that it is basically 0, so we can get rid of the terms including H. 12 T. And we're just left with 12T squared plus 6T squared, which we can simplify to 18T squared, which is our limit of the difference quotient here. And then now we just need to figure out, we just need to plug 3 in and figure out our instantaneous speed at 3 seconds. So all we do now is plug in 3, 18 times 3 squared, 18 times 9. And we'll get that our instantaneous speed is (162 meters per second). That's how you find instantaneous speed.